Okay. So how many of you completed assignment 1 and 2 in digital logic design? Combinational logic circuit, have you completed? Harshit, is this your first session? Hello. Sagar, have you completed assignment 1 and 2?
Hello?
In digital logic design and Verilog HDL, first assignment.
I did some of the problems, ma'am.
Okay. What about Lahari, Pranita, and Suma?
I completed assignment 1, ma'am.
Assignment 1 from digital.
Yes, ma'am.
Okay. What about Verilog? Yeah, please tell Sumalata.
Yeah, sorry, continue.
Yeah, you can talk.
Mine is first assignment 1 is almost complete, and second is not yet started, and Verilog is I solved some of the, almost 7 or 8 I finished.
Okay. Okay. So yesterday we have a discussion regarding whether to start Verilog HDL and digital electronics parallelly or to complete digital electronics first and Verilog second, right? So I'm thinking that in 3 days sessions, we have weekly 3 days sessions. Before we discuss that whole like 5 days is a Verilog HDL and weekends will be digital electronics, right? That's what we thought. Let me know whether you are getting time to practice the assignments or not. Okay, if you don't get the time to practice assignments, then we will get with the better solution based on your availability. Okay, based on your convenience. And I'm thinking like in whole week, we will keep 1 day for digital logic design and 2 days for Verilog HDL. Okay, so initially, so whenever digital logic design concepts required, suppose yesterday we have completed basics of Verilog HDL, just how to write the programming and all. Okay, suppose today if we discuss data types of Verilog HDL operators. Okay, in the next session we will discuss on combinational logic circuit. Combinational logic circuit already completed, but there are a lot of things to discuss. Okay, I didn't discuss it in the interview point of view. I just given only overview. But in interview point of view, how we can design the multiplexers, different logic gates using the multiplexer, different logic gates implementation, 2x1 marks, 4x1 marks, or demultiplexers, hierarchical connections. There are a lot of things to discuss in a interview point of view. Okay, for those things we will have a discussion for digital electronics separately. Once every concept of digital electronics is completed, parallelly we write the program for each circuit. Okay, so if combinational is completed, every code we need to write. For full adder we need to write at least 2 models. We discussed 4 models in Verilog. Data flow modeling, behavioral modeling, structural modeling, gate level modeling, switch level modeling, right? But at least 2 models we need to write for every circuit, every digital circuit, half adder, full adder, multiplexer, demultiplexer, and not only those styles, how easily we can connect. Okay, like logical ways, like yesterday we have seen. Can you mute? So yesterday we have seen some like for full adder how to write the program in single line logic concatenation operator, like that multiplexers, demultiplexers also. There are a lot of models to discuss. Okay, so parallelly we can complete digital electronics, or if you want to complete me first digital electronics and then Verilog if you want to learn slowly, that also we can do, because digital electronics also most important. Okay, in interview point of view, that's your wish. Okay, you can decide, you can talk in team yourself and let me know. Just come to conclusion. Based on that I can schedule the sessions. If you want to learn RTL parallelly with so you will get the hands-on experience, if may think like that, so we will plan RTL parallelly and digital logic design parallelly, but don't confuse with the assignments. Okay, don't take stress to complete the assignments. Okay, take 1 week time to complete for digital logic design assignment, next week for Verilog HDL assignment. Okay, suppose till now I have given 3 assignments. Okay, don't take stress. Otherwise you will get confused which one to submit and which one to work. Okay, so 2 digital electronics assignments are left. So by this week everyone try to complete the digital logic design 1 assignment. Okay, Verilog HDL by Sunday. Okay, better you can take a 3 days time for digital logic design, 3 days time for Verilog HDL assignment. Okay, so that would be better, I think. So parallelly for each assignment you can take 1 or 2 week time. If I want to reduce the number of questions, I can reduce the number of questions. In each assignment, I have given 30 questions nearly. So if you want to reduce me, I can reduce number of questions from next assignment. Okay, but no need to worry. Whatever number of questions you are able to do, just do. Okay, if you are not able to complete, no problem. In future you will get the time to practice. Whenever you get the time, just practice it. Okay, so first 3 days digital logic design, next 3 days Verilog HDL. Put the time like that, and every assignment you need to be submitted to the mail. Okay, to the mail or in a group. I think I already created a group. You can share in the group in a Teams. Okay, so another thing is, yeah, that's it. If you need any extra sessions, we will discuss on Sundays also. As of now we schedule for 3 days only, right? Monday, Wednesday, Friday, 3 days. So if you want to take me in Sundays for half an hour or 1 hour to discuss digital logic design, we can schedule. Okay, so 3 days will be enough, more enough, because as per the assignments. Okay, yeah, that's it. That's what I want to say. If anything is there from your side, just you can let me know, or else I can start the session. Hello.
Yeah, ma'am. Okay.
Okay.
Start then.
Okay. So for today we will discuss on Verilog HDL data types. In the next session we will discuss on digital logic design, combinational logic circuits. Okay. So coming to the Verilog HDL data types. So I think everyone understood, right, what is meant by behavioral modeling, data flow, gate level, switch level. Okay. So next, how to write the program. Can you tell me what are the differences you have observed for behavioral modeling and data flow modeling? What are the main differences in terms of coding?
Hi, ma'am. We need to use always for the behavioral modeling and
Okay.
assign for the data flow modeling. That
Okay.
difference I have observed.
Okay.
And we also have switch, case and if condition in the behavioral modeling.
Okay. Yes.
And for data flow modeling, it is like simple logic. It is.
Okay. Yeah,
That's
very
it.
nice. Okay. So what is the difference between always and regia? Why we are declaring output as a wire and data type? Wire and a reg.
While doesn't store any data, register will store the data. And while in always, if we are using register, we have to give non-blocking assignments.
Okay.
That I have observed. That is giving error. If I won't put any register for any variable, in always block, we have to assign in the non-blocking assignment.
Okay. Okay. So those things we didn't discuss, not discussed in the coming sessions. We will discuss. So main the difference between behavioral modeling data flow means behavioral means we will write for truth table logic functionality, and data flow means we write directly expression. We will put the assign. We just use the keyword assign, that is a data flow. If we use keyword always, that is a behavioral modeling. Okay. Gate level means just we will put all the primitives, gate primitives into the design. So it's a gate level modeling, and switch level modeling means in terms of PMOS, NMOS or CMOS, we write the program. That is what switch level modeling. And test bench, we already seen the test bench also, right? Next, so what is the difference between synthesis and simulation?
Simulation means just functional verification, like whether we are getting an output or not. Synthesis means like converting the code into gate level netlist.
Okay. Okay. So synthesis is nothing but we have already installed the tools for synthesis and simulation. Synthesis is nothing but writing the program and generating the circuit netlist by using the tools. And simulation is nothing but whatever the circuit netlist we have generated, we apply the inputs to the circuit and checking the output. That's what we call simulation, nothing but verification. So in verification here we write the test benches. Okay, to the design we write the test benches, but if we go forward in system verilog we write the complex test benches. There we do the functional verification, formal verification. Okay, so that is what the difference between synthesis and simulation. Harshit, do you have idea on this before on verilog? Hello. And Rakib Hassan, are you able to understand? Have you completed the assignments?
Yeah, I already checked it and I'm working on it. The
Okay.
assignment one. But I don't have that much idea for the HDL.
Mm-mm. Okay. So did you understood behavioral modeling, data flow, switch level, gate level? What is
Maybe I
what?
can give you the
What is what?
feedback after the lecture when I'm going through with this one.
You are going
I
through
need,
recorded session, huh?
yeah.
Okay. Okay, fine. Okay, then Verilog data types. Okay, so today we will discuss on Verilog data types. In Verilog HDL, we have majorly two data types. Okay, so one is a net data type, one is a reg data type. Net and a registered data type. So net data types are classified into different data types, majorly wire data type and W and WR data type. Wire, wire and wire or data types. Okay, and these try zero and try one, supply zero, supply one, try reg, these are not much required. Those are used for CMOS transistor level. Okay, for if you want to write the program in transistor level, we use there will be tri-state buffers, right? So in that case we use this, but these are not much preferable, because anyway we are not writing the program in CMOS, right? CMOS level. We are majorly considering behavioral modeling, data flow, and gate level. Okay, so we use wire data type mostly. W and W are also okay. Sometimes not mostly, just in some most of the requirements like a multiplexer and demultiplexer, so we use W and W or. Okay, I will show you, then you will get understand. Next thing is a register data type. Variable data types are nothing but register data type. Okay, so register data types means reg, integer, time, real. In register data type, we will have two types of data types. Okay, so one is a synthesizable, remaining all are non-synthesizable. Can you tell me what is meant by synthesizable and non-synthesizable? Can you tell me what is a synthesizable and non-synthesizable?
Synthesizable means it converted into gate level netlist, ma'am.
Okay.
Non-synthesizable means it can't connect. Like wire is there. Wire.
Synthesizable means a gate level netlist.
It converted into any gate. Like for example, display is there. Dollar monitor, dollar display.
Okay.
These comments are won't converted into any gate.
Okay. Okay. Non-synthesizable means?
Optimization is not happening. Yeah, whatever is there, we need to use the same thing.
No. It's not related to optimization.
Synthesizable means maybe we can convert it into hardware, and non-synthesizable means we can't convert it into hardware. We can't represent it as a hardware.
Hardware. Okay, fine. So synthesizable means same whatever she told, which is converted into the hardware. We can do the synthesize and generate some netlist. Any block, whether it's a small block or it's a complex block, whatever, we can generate some circuit netlist for that, which is nothing but design or hardware. Okay, non-synthesizable means we cannot generate the circuit or any netlist. These are used only for verification purpose. Before that person said, right, dollar monitor, dollar display, dollar strobe, these kind of things are used in test benches. Okay, so mostly test benches are non-synthesizable. Why? Because through the test benches we don't generate any design, right? Any hardware or any netlist we never generate from test bench. We only generate from design code. Okay, so the design code is always synthesizable. Test benches are non-synthesizable. Okay, so that's why we use synthesizable reg data type in the designs, which are synthesizable. Integer, time, real we use in the test benches, because those are non-synthesizable. In test benches, they doesn't generate any circuit diagram. Okay, so if you use these in design, what happens? We never use in the design. Why? Because those are not applicable to declare any variable, because in the design all the connections or all the variables are connected one by one. Okay, one gate to another gate, or one block to another block, one logic to another logic, everything, the connections will be there in a hardware level. Okay, if you want to connect these things in a design part, we cannot connect. If you want to use the design data types in test bench, we can use that. If you see in the test bench first, in the last session we have written inputs as a var data type, outputs as a reg data. Inputs as a reg data type, outputs as a var data type. But I didn't tell you why we have written that. Okay, in the next coming sessions, we will discuss why we have written that. Okay, so in register data type, we have two types. One is a synthesizable, non-synthesizable. Okay. Next, what is mean by wire data type? We already know what is mean by wire. We discussed, right? So one-to-one connections. These here A, B are the input ports, CD are the input ports, main input ports, and output is the output port, main port. Okay, but here X and Y, these are not either input or output. Okay, these are just interconnection between one gate to another gate. One gate output is given to another gate of the input, and here also AND gate output is given to the input of the OR gate. Okay, these are just internal connections. So whatever the internal connections are there, those variables we declare as a wire data type. Okay, so if you see the example here, module example, input A, B, C, D, output out, wire XY. Okay, so XY are declared as a wire data type, and assign X is equal to A and B. So end operation of A, B, that is assigned to X. Assign Y equal to C or D. Y equal to C or D, and assign out equal to this X or Y. Okay, so this is how we write the wire data type. Everyone understood? By default here, input and outputs are which data type? By default.
By default, wire, I think.
By default wire data type, right? So if we didn't declare anything there, input just A, B, C, D, output out. If it is a register data type, we need to put as a reg. But if it is a wire data type, specially we don't need to put as a wire. By default, every variables are wire data types only. Okay. And what is the main difference between wire data type and register data type? Can you tell me? What is the main, this is the most asked interview question. What is the difference between wire and register data type?
Register data type, we can store the data, whereas in wire we can't.
Okay, so
It
as
is
I
just
told,
a
wire is
connection.
just a connection, sir. And that too, wire is mostly used for combinational logic circuit. Remember everyone, mostly used for combinational logic circuit, because combinational logic circuit doesn't store any data. Same as wire also doesn't store any data. Okay, but register data type stores data. In the name itself, register in the sense it stores some data, right? And number of bits. So mostly used for sequential logic circuit, to declare the output of sequential logic circuit. Okay, whenever we are writing program one by one, you will get understand, and also we need to follow lot of rules. Okay, so that is what the difference between reg and wire. Clear everyone? Okay, so if you have any doubts, let me know. Next, W and WR. What is the difference between W and? Nothing but wire and wire OR. Okay, so if you observe here, XOR gate. Okay, so inputs of the XOR gate are A, B, and Y. We didn't mention any variable. And AND gate inputs are C, D, and output we didn't mention any variable. Okay, so the declaration wise, inputs are A, B, C, D, and wire AND declared for Y, wire OR declared for Z. Okay, so assign Y is equal to A XOR B. So here A XOR B assigned, and Y is equal to C and D. C and D assigned. But what is the Y here? Y is by default W and Y. If you just put as a wire Y, it just a wire connection. But here we mentioned as a wire AND. That means by default it will generate the AND gate for all the connection. This connection to this connection, it will generate a W AND, wire AND. Okay, even you put multiple number of connections, any number of connections you can put, it will generate one AND gate to the output. So how it looks like, which circuit diagram, which is a similar circuit diagram in digital logic design?
like multiple inputs and single output.
Multiplexer. So multiplexer also we can declare all the inputs one side and final output we can declare as a W and Y. Okay, so all the inputs you can assign, you can write like this using assign statement or expression, and you can connect all with a Y. Okay, just try that example and let me know. If you don't get, I will explain in synthesis. Okay, so this is one question, assignment question for today. Next, assign Z is equal to E or F. That means here E or F, Z is equal to not G, not G. So for which it is connected W or Z. So Z. So Z means W or Z means by default this connection to this wire connection, we will get one OR, W or gate, OR gate. Okay, so these all are synthesizable. All are synthesizable means it will generate the circuit netlist, and which all are combinational logic circuits. Okay, clear till here? Everyone? Any doubts? Next, register data type. So register data type, we have three data types. One is synthesizable, remaining all are non-synthesizable. So if you observe here, module A, B. A is declared with a 4-bit data type. 4-bit means 3 down to 0. Okay, so 4-bit means you will be having 4 number of locations like that. The third location, second location, 1, 0. So 4 number of bits we can store. If it is a 1, I already told, right? 1 bit means no need to mention like this. Just we will put reg A. So it is a 1 bit. That is scalar format. If it is having multiple bits, it's called vector format. Okay, you can write a 3 down to 0 or 0 up to 3. Any format is same, 0 up to 3. Then it will be MSB will be started from 0, 1, 2, 3 like this in this format. Okay, before 3 down to 0 means 3, 2, 1, 0. Like that. Next, B is storing 8-bit data, 7 down to 0. So that's why 7, 6, 5, 4, 3, 2, 1. So in this we can store any data. If you can also put 0 up to 7. 0 up to 7 means 0, 1, 2, 3, 4 like that. Okay, so this is what reg data type, which store the data. That's why we will declare as a reg. Even it's an input or output, we can declare as a reg. Okay, but most of the students they do some mistake. What is that? In the design, suppose it is a design code. In the design code, whenever declaring A, B, they will declare 3 down to 0, 7 down to 0. Okay, but in the test bench program, same we need to write A and B, we need to declare, right? So whenever they are declaring A and B here, they just mention 0 up to 3 and 0 up to 7, reverse. Here they just kept up to down, but here down to up. So what will happen that time? Suppose in a test bench you are taking A is equal to it's a 4-bit, right? A is equal to 9. Okay, so 9 means how much value? 1, 0, 1. Oh, okay, not 9. Suppose 8. 8 means how much? 1, 000. Okay, so in this test bench, this 0 down to 3, 0 up to 3. So it will consider 0 location, 1, 2, 3, and it store 1, 000 like this. Okay, but same value if it is going to design, so how it goes to design? As you are writing here 3 up to 0, okay, so 3 up to 0 means the same location it will consider as a 3, 2, 1, 0. See how much a mismatch it is getting between test bench value and the design value. Both are not matching. So we will get a wrong output. Okay. So most of the cases we will get the wrong output. So that's why whenever you are writing one format, follow both for test bench and design, follow same format. Okay, either up to down or down to up. Clear? Hello.
Yes, ma'am, clear.
Next, initial begin a equal to something 1010. I already told you. If it is a 4-bit, we need to mention as a 4. Tick, these all are binary values, so we need to mention B. If it is a 2-bit, then 2 tick binary value 10 or 01. 8-bit, then binary 8 tick binary some 8 values, 8 bits. Like that 8 hexadecimal 9A hexadecimal value. Hexadecimal value means each value will be 4 bits. So here 9A will be divided into 4 bit, total 8 bit. Okay, only two values, two digits are there. So 9 will be converted into the binary, suppose if you write, and A will be converted into 10. So the total 8 bits. So if you want to write a 16-bit, then hexadecimal 9A B2. So 9 will be divided into 4 bits, A 4 bits, B 4 bit, 2 4 bit, 16 bit, like the 32 bit. Each digit will be 4 bits, like that we will divide. And next dollar display. In test benches, we will have dollar display, dollar monitor, dollar strobe, like these kind of simulator directives. We call as a simulator directives, but as of now, no need to worry. I'm just telling overall. Okay. In the test benches concept, we are going to learn everything. How to write dollar display and dollar monitor strobe, right? And also we have to dump the waveforms. To open the waveforms, we have dollar dump file, dump where, dump on, dump off. So we will discuss everything clearly in the test bench concepts. So dollar display and quotation marks, within that we can display the statement to print something in the console. Okay, so a equal to percentile b, we already discussed about the format specifiers, right? Percentile b, so it print in binary, comma a, and b equal to percentile h, it print in hexadecimal, comma b. So this is what example for reg data type. So we'll do the simulation and we'll check the output. So model simulator, is it working fine? Sumilata, if you can share the screen, I will show you how to do the simulation in model simulator.
1 second.
You can share afterwards. So,
And my quarter frame also, it got stuck. It is not responding. I wanted to ask you to check once. At end of the session, I will share.
okay. Okay, see here. A is equal to 1010 binary value and B is equal to hexadecimal value 9A. Okay, so instead of H, if you put B here, hexadecimal value 9A also, it will print in a binary only according to the format specifier. Okay, see, binary value. B is equal to 10011010. Okay, any doubts still here? Did you understood everyone the reg data type and vector format, scalar format?
Yes.
Next, how to use a time, real and integer data types. So time is nothing but just it represent the simulation time, present time. Suppose in the last session we have seen some when we are written for ripple carry adder program, in the input we have given 3-bit values, 8 scenarios. So in that 8 scenarios, the last scenario is printing, only last scenario, because previous all 8 scenarios are taken at a 0 simulation time. We didn't mention any time simulation delay. Okay, so if you don't mention the delay, all values will be printed at a last time, simulation time. Okay, present simulation time. So for that purpose we need to put the delay. So whatever the delays we have kept for each statement, if you want to see in the console at the output statement, then we need to use the $time. $time is a system task, same as a $display, $monitor. Okay, next is a real value. Real value means a decimal values. Okay, so decimal values means in a C language, suppose if there is 1.1020 like that, 0.11, so those type of decimal values we represent using a float data type. Okay, but in Verilog HDL we represent as a real number, real data type. Okay, so that is what real. And integer. Integer means it represents the 32-bit data. Okay. So module test bench, integer A, real B, time C, initial begin. A is declared with some value, B is declared with some value, C is equal to $time at 20 time units. So B, A, B, C are printing here. Okay. So what is the output? So what is the output? Can you tell me? Are they correct? A is equal to minus 17037, some value is printed, B equal to 0 and C equal to 20. So what is the correct answer for this? Actually here we declared A is equal to hexadecimal 9A723456 something value, B equal to some float value 0.23651, and C is equal to $time 20 time units. But why it's not printing the same values? And another thing is, if you observe, some values are starting at this point of time and some are taking the space like this. And if you write more number of variables, there will be lot of spaces and nothing but all are not in a same format and same line. Okay. So in that case, what we can do to print all the statements in a single same line in a order, in a same order.
I think we need to give the same delay for all the variables. I mean to say 20 millisecond for A and 20 millisecond for B, which is same
First,
as C.
okay,
Yeah.
same delay. Okay, so if we give same delay, what will happen here?
It will generate the space.
No. delays are just to suppose another thing is here three variables or three different variables, a b c or three different variables. Okay, so in this case even if you write the delay or not no delay, that's not a problem. Whenever you are taking a one single variable multiple times, then we need to mention the delay between each cycle. Suppose a you are taking 10 number of values, 10 number of times you are changing. Okay, so if you want to check every change of the value, then every change of the value should have the delay between each value change. Okay, so that's why we put delays. Suppose here a is declared only one time, but if you declare a as in many times, suppose I am declaring three number of times and different value. Here I am just putting 1, 2, 5 or 4, 5, 6, 3. Okay, now for this a, what value you will observe at the output side? So definitely you will observe this value. Then you need to put the delays between these two a's. Okay, so where the delay work means this is how. But how we can reduce the distance here and how we can put all in same order. How in the sense? Here at the dollar display statement, there is a equal to percentage D format specifier. Okay, so D or H or O or B, whatever. Here we need to mention the width like this. Okay, 0. So 0 is a minimum space, like 1 bit, 1 space. If you put a 1 D, it add 1 space. 2 means 2 spaces, 3 means 3 spaces, 4 means 4 spaces, 5 means 5 spaces, like that. Okay, so if I do run and check, see, all are printing at the same line. Okay, so that is what we can do. Suppose if you put as a 5, I'm putting first one as a 5, remaining 2 or 0. So 5 means a more number of spaces. Why it's not taking? 5 means more number of spaces. Here it is getting. Here also getting 5 number of spaces. Suppose here I am putting 10. 10 means compared to 5, it takes more number of spaces. First statement, it is not working. Okay. Okay, see here, 5 number of spaces, 10 number of spaces and 0 number of spaces. First one, why it's not working, I will check once again. So this is how we can add the spaces. Okay, everyone understood? Everyone clear till here? Hello.
Yes, ma'am.
Okay, next thing is here why it is printing, why it is not printing this hexadecimal number. Why it's printing some value 1164, something like that. Why? Because here we mentioned hexadecimal. Okay, if you want to print same hexadecimal 9, A, 7, 2, 3, like that, output format specifier also we need to put H, hexadecimal. Okay. Another thing is B equal to 0.23651. We assign float value, real value. But here it is printing only 0. It's not printing entire real value. So what we can do? In the first session, I told you what is the format specifier to print the real number. What is the format specifier to print the real number?
Is it G, ma'am?
%G. Okay. So to print time, we use D, or you can use any of, mostly we use a D only because it's a integer. Time is a integer. Okay. So run. See what is the output now? A equal to 9A 723456. So exactly whatever we have given, same value. B equal to 0.23651, same. And C equal to 20. And all are printing at the same value, same line. Okay. Is it clear, everyone?
Ma'am, I have a doubt here.
Okay.
If you want to print ceiling value of B, how we
Value.
can do? Yeah, how we can do?
Ceiling value, we cannot print like that. Ceiling value and what we call another ceiling means a down, right? Up.
Up, and float means down.
Okay. So float means directly we can put G, but here in this case we don't have ceiling or float. Just we will write the real value in Verilog. We don't have the options to write the flow ceiling like that. Okay.
Okay, okay, ma'am.
And next, before you told the delays will be taken, right? So here I'm considering 3 number of A's. So if I consider 3 number of A's without putting the delay, that means all A are executing at a 0 simulation time here. So finally, whatever the value is there, final 0, that will be printed here, 45633 So if you want to check every value of A, so every value of A, we need to put some delays. Suppose #5, here also #5. Like that, we need to put the delays of each. So it will print like this. Every value. Okay, every value will not print. Why? Because $display we used. So $display means it prints only immediate value. That's why here I need to put $monitor. Dollar monitor means it monitor every change of the input and it will print all the changes. A is equal to 456. Okay, see, A is equal to 9A 723 all printed, 1 2 3 5 2 printed, and A equal to 45633 all are printed. Okay, clear here up to here, everyone? And another thing is, here delays you mentioned, right? #5, #5, #20. But here output side delays are not printing. So if you want to print delays with the delays, then we need to write a $time in the statements. $time here and here and here also. So that with the time delays, the statements will be printed. So mostly we need to write the test benches in the same way. See, 0 simulation time, A first value, next 5 simulation time, because 5 we have given the delay here. Next 5 plus 5, 10. Next B will consider it 10 simulation time only, it should consider. C at a 30 simulation time. Okay. Why B is considering at a 30 simulation time means $display is written after C execution. That's why B is considered 30 time units. Okay. But if you put $display after B, not here, not after C, just after B, then it will print 10 simulation time. C, B10 simulation time it is printing. Okay, so that is what order of execution. Okay, clear everyone? Any doubt still here? Have you understood the difference between wire, WR, WN, reg, integer, time, real? Any doubt still here?
No, ma'am, it's okay.
What about Harshit, Sagar, Shranita, Lahari, Suma?
Yeah, good for me.
No
Okay.
doubts, ma'am.
Okay, so these all about data types in Verilog HDL, simple data types. Okay, next topic is operators. Basically, in every batch, operators I won't discuss personally. So I will give as an assignment for operators for arithmetic, relational, equality, logical, bitwise, shift, reduction, concatenation, replication, conditional operator. So you need to work on operators program. Just not no need of program as of now. Just need to understand how do we do arithmetic or relational, mostly the difference between logical, bitwise, and try to understand. Okay, so I will explain you few examples of operators. Suppose arithmetic operator. Arithmetic operators means addition, subtraction, multiplication, division, modulo. Modulo in the sense reminder it will print, and a power. Okay, two starts. Suppose 5 power 3. Then we will write 5, 1 star, 2 star. So 5 power 3. It represents like that. Addition you already know. So if you see here, A is equal to 45, B equal to 9. A plus B. This is one style of programming. Very optimized way. Okay. So mostly what everyone do means first they will write, they will do C is equal to A plus B, extra variable for output. Then display statement like that. C is equal to A minus B, C equal to A into B. Without writing like that, directly in the display statement itself, we can write A plus B that will be assigned here. Okay. Next, A minus B, A into B, A by B, A modulo B, B power 2. B is a 9, power 2, 9 power 2. So these values will be printed directly here, display statements. Okay. So try to write the program, take time tomorrow. Try to write the program on arithmetic operators. Okay. So anyway, in the next session, we will discuss, I will ask some questions on these. Relational operator. You just check output will be single bit, either true or false for relational operator and for logical operator, and yeah, for these both relational and logical, we will get output either true or false. Okay, because it's just checking whether it's correct or wrong. Okay, so A greater than or equal to B. If S true, A is less than or equal to B. A is greater than B, A less than B. So here are the program. First, we will declare A as a reg data type, B with 8-bit data type within the initial begin. I will explain later in the coming session what is meant by initial block, what is meant by always, begin end, all these things. Okay. So A equal to 45, B equal to 9. Checking with A is greater than or equal to 5. So it's a true. True means we will get as a 1. Just a second. Hello. Yeah, hello. Yes, yes, I'm sharing. Share it in group or in first. Okay. Okay, so here it check with A is greater than or equal to B. So if it is correct, output will be 1 or else 0. And A is less than B, A greater than B, A less than B. Just once practice from your side. In the next session, we do the simulation and we will check the result in the console. Okay. Next, equality operator. So what is the difference between equality operator and arithmetic equality operator? So equality operator means only two equal symbols will be there. Okay. And not equal. Not equal means one negation is equal to. Like that arithmetic equality operator. Arithmetic equality operator means three equal tos. And one arithmetic not equal means not equal and two equality operators. Okay. So check A equal to 45, B equal to 9. So what is the output and what is the difference between these two? Okay, you need to get the answer. And next, logical operator. As I told, output will be either 1 or 0. In logical operator, we have only three type of operators, that is logical and, logic or logic not. Okay, logical and means what? Logical means every value will be considered in either logic 0 or logic 1. Okay, so here A equal to 5, B equal to 9. So 5 and 9 are other than 1, other than 0 values. So whatever the other than 0 values are there, it will consider as a logic 1. Okay, so it will consider A as a logic 1, B as a logic 1. So 1 into 1, 1. And X. X is also other than 0 value, right? So okay, X means either 0 or 1. Okay, so if 0 into 1, if you consider suppose X as a 0, then 0 into 1, it's a 0. Okay, so output will be 0. Like that Z into B. Here Z will be high impedance. High impedance means it's other than 0 value. Other than 0 value means obviously it is a high only. Okay, 1 into 1. It will consider 1 into 1. Output will be 1. Here it's given wrong. Output as a 1. Okay, Z is a high impedance value. So it will be considered as a high. Next term, A equal to 4, B equal to 9. 1 plus 1. It's a 1. And also A equal to 0, B equal to 4. So 0 plus 1, 1. Next, not operation. For not operation also same. 0 not. 0 not means 1. Okay. So output will be whatever the input size, output will be logic 1 or 0. Okay. In the same way, we have bitwise operators. Bitwise operators means we have logic not, bitwise not, bitwise and, bitwise or, bitwise XOR, bitwise XNOR. Okay, you will get just you will get the confusion with these. See, in the interview point of view, they will just give like this A and B. So you need to understand whether it's a logic operator or A and B. They just give like this. Immediately you need to see and understand whether it's a logical operator or bitwise operator. Okay, both are different, both are not same. Okay, so bitwise operator, it represents with one value, one character only. Okay, so for bitwise operator, whatever the input size, output size also same. But in logical operator, whatever the input size, output size is a single bit. Okay, so suppose in bitwise 0001 and 1001. So 0001, 1001. So bitwise means every bit to bit we need to do the operation. So 1 into 1. So here not a, okay, not. Suppose next one A and B. A and B means 1 into 1, 1. 0 into 0, 0. 0 into 0, 0. 0 into 1, 0. So output will be 0001. Like that A or B. So for we do for both. That's why whatever the input size, output size also same. A XOR B, A XOR B. just do the calculations and check the output. Okay. Next is shift operators. Shift, right shift, left shift. Check, just check and let me know if you have any doubts. Reduction operator, work on reduction operator, concatenation, replication, conditional. These 4 operators. If you have any doubts, we will discuss in the next session. Okay. And mostly in the next session, we will discuss combinational logic circuits in interview questions. Okay. And then we will start with the description styles. Once the description styles completed, we need to design all combinational logic circuits. And then we will discuss the sequential logic circuit, flip-flops, registers, counters, detailed. Then we will start designing latches, flip-flops, then registers, counters, like that. Okay. Any doubts still here, everyone?
No, ma'am.
Clear? Okay, so today assignment is in data types. I have given one question to work on multiplexer by using a W and a WR and in operators. Okay, that is what assignment you need to come with next session with the answers. And remaining, I already shared the assignment. So whenever you get the time, you can work on those. Okay. But priority assignments or whatever we discussed in the current session. Okay, once you get the clarity of today's session, then only next session will be useful, right? You can understand clearly. Remaining assignment you can do parallelly whenever you get the time. Okay. Any doubts from Rakib? Okay, fine.